project organization, firstly, our project manager is Lau Siwen. So, Lau Siwen will lead and guide the progress of all of the members and distribute the task evenly to all of the members. And our process engineer is Muhammad Badrul Amin, which he must describe process with block flow diagram and handle and lead progress of design basis. And for research and development engineer Nurul Amira binti Sabri, she will describe process with block diagram flow and handle and lead progress of design basis, which she will work together with Badrul Amin. And for the occupational health and safety officer, Syafiqah binti Jamaluddin, which she handle all of the process inside the plant that involve health and safety. And for the cost engineer, Nur Wahida, he manage all of the costing, and also sales and marketing engineer, which is me, Zahra Izzati, prepare quality function deployment, basically all of the things that involve customer. Okay, for the commercial analysis, we identify our competitive product, which is from the Tropok Fan Foods Malaysia, RF Foods Industry, and also the Rina Food Industry. And also we identify the products or services, the target market, strength, weakness, opportunity, and threat for each of the company, so that we can make all of the value to improve our own product. And for the market forecast, Market Intelligence Agency said that the ready-to-eat meal is expected to reach 46 billion for the next and have 10.6% forecast, which for the ready-to-eat meal, which is the ready-to-eat meals market value is 72 billion at 2016 and expected to reach as 146 billion for 2023, which is in industry. It is expected that the ready-to-eat meal in the marketplace will be increased, and we also think that the Rina food industry, the sales growth is maintained 30% every year, so that we can see how do the Rina's industry operated as our guideline to improve of our products. And this is all the benefit or the feedback from all of other company, so that we can take this as our guideline to improve our products.
Okay, I am Nurul Amira. I will present about the design objective. Okay, so our product specification is ready to eat meal, which is fully prepared or pre-cooked meals, either in frozen or at ambient temperature storage, which can be bought from retail stores and we can enjoy it everywhere. Ready to eat meals usually packed in pouch or tray, which is more convenient and mobile. In the ready to eat meal, it consists of carbohydrate, protein, and vegetables, which is a balanced diet. For the customer requirements, we use the application of quality function deployment (QFD) with the construction of house of quality. The QFD is a method to define the customer requirements, and we plan to produce a product that can fulfill those requirements. And this is our QFD, which is from the number here. We can see that the highest value is 159 on the method of cooking and processing. And we can see from the customer requirements, the customer wants the meals to be easy to serve, it is tasty, and it can be stored at ambient temperature. So we can conclude that from here, we more focus on the method of processing to fulfill the customer's requirements, such as we want to produce the meals that can store at ambient temperature. Okay, for the technology description, we use the raw materials chicken, which is deboned breast, because it is easy to handle in the dicing process because it has no bone and it can cut the cost at the machine. Other than that, the deboned breast also has the highest protein content other than the other parts of the chicken. And also basmati rice for the carbohydrate. Then process chemistry. The first process is washing. So in the washing process, we use the filtrated water by the Catry filtration. The second process is dicing. This is to cut the small dices, the food into the small dices to ensure the food is evenly cooked and to ensure the cooking time is reduced. The dicing also, we want to prepare the bite size of the chicken and the potato. Okay, then the third process is peeling of the potato, which is we use the mechanical peeler. It is more efficient and reduce product loss and reduce production time. Okay, then we have the cooking process, which is the cooking curry chicken and the steamed rice. The fifth process is primary packaging. We use the CPET, which is crystalline polyethylene tetrafilate tray, which can stand higher temperature up to 2020 degrees Celsius. And then we have the film at the top of the packaging, which is manufactured from layers of laminated foil to withstand high temperature and pressure during the sealing and retorting. Next is retort sterilization. The food is sterilized at high temperature up to 100 degrees C to ensure maximum microorganisms can be killed and the products can withstand for a longer time and have longer shelf life. And then secondary packaging is the corrugated carton box. And the last process is storage.
So for task 3 is about the process description. For the definition of the project, the first aspect is the customers. Our customers will be mainly about will be the housewife or those who miss home. Like why will our customers buy our product is that because the reduction in house cooking and also family size due to nowadays the people are getting more busy, right? So and then the rise in income level also helps to purchase of our product because they can just buy because they can afford the product, so they can straight away buy and don't need to cook. So after that, the next point is more frequent global trade and travel. So those who travel around the world frequently, when they miss home, they can try our product, which is the typical Malaysian flavor. And then for the next one is the plant location, where the selection criteria is very important. We have to make sure our plant is near to the market or raw material so that the supply of raw material will not be stopped, and this will cause the the breakdown of our production line. So the next criteria is that we want to have fast transportation, and also we want to have the constant availability of utilities. And then the next is key fits, which is about the raw materials. We have 3 main raw materials, which is the chicken. And we have to store the chicken in freezing storage, which is less than 4 degrees Celsius. This freezing storage is very important, and then it is one of the CCP in the hazard plan. Then after that, for butter, which is one of the dairy product, it has to be stored away from the other food raw materials because it has fats and the fats will absorb the odor. So after that is the others, which is dry food, like for example those potato, onion, rice, all those. And then the storeroom has to be near to receiving, easy to clean, free from pests, cool and dry, and easy for arrangement. So after that, for our products, our product is ready to eat butter basmati rice with chicken curry, which is 400 grams in total, and then it is shelf stable due to the process of retort sterilization, and we also use a proper packaging, which is 2 compartment CPET trays, which can withstand the temperature from -40 to 220 degrees Celsius, and they will be packed inside a corrugated boxes or display boxes to make sure they are well protected. And then our product will also fulfill the ISO 22000 and also halal certificate. So for the plant capacity, the plant capacity refers to the maximum quantity that can be produced by 10 units in the plant with existing equipment. For this will be explained in the design basis later. So for production rates, it is to test the efficiency in the production line. So the production rate will be about 5,250 packs per hour, which in order to hit the target of 10 million packs per year. So this
can be achieved by adding similar unit operations for those process which will take long time. Like for example, mixing, we have to mix it for quite some time to make sure it's even and it's constant. So and then we have to make sure that our plant is near to raw material supplier so that this one will not affect the production, and also we have to minimize the cleaning time and also recipe changes. Okay, for the purity specification, we don't add any artificial additives so that it is more healthy for consumption. And for the chicken curry and basmati rice, we have all these other components inside. And also this is the project scope where our packaging is aimed to delay the deterioration of the food product, and also we want to prolong shelf life, and also we have to make sure our quality is always okay. So this you can see that after being retorted, the storage period and all the characteristics will not change much after the storage. Okay, so the design concept is that we want to package using the retort sterilization is almost all the same. And then the alternative is that there will be one alternative, which is we don't want to use CPET tray, maybe we can try pouch. Pouch has the good barrier properties and it's also flexible, but then the FFA, which is the fatty acids, and that one will change with time, and then the production rate is also slow and it's not so convenient. So you can see that this is our design basis. Next. Okay, this one is the production rate, which for butter basmati rice is about 1.31 ton per hour, and the chicken curry is 0.786 ton per hour, and the total is 2.096 ton per hour. And then this is the supply required for each of the raw materials, which will be discussed in detail for the next one. Yeah.
For my task, I will explain about the mass energy balance. For the washing of rice, it assumed to be lost about 3.4 kg per hour, and the total rice at the outlet will be 300 kg per hour. And for the mixing of the butter rice, total loss at the process will be 6.6 kg per hour, and the total wash rice at the outlet will be 1,300 kg per hour. Okay, for the cooking of the butter basmati rice, the total loss to the steam will be about 12 kg per hour, and the total cooked rice will be 1,300 kg per hour. For the preparation of the protein sauce, washing of deboned chicken breast, the total loss will be about 5 kg per hour, and the washed deboned chicken will be about 500 kg per hour. For the dicing of the deboned chicken breast and the dicing of the red onion, we assume the outlet, the inlet will be same as there is no loss during this process. For the mixing process of the spices and red onion, the total will be about 200 kg per hour. And for the preparation of potatoes, during the washing, the total loss of the dips about 0.4 kg per hour, and the total outlet clean potatoes will be about 41 kg per hour. For the peeling process of the potatoes skin will be about 0.2 kg, and the total potatoes at the outlet will be 41.7 kg per hour. And as for the dicing of the potatoes, we assume the outlet will be same as the inlet, such because of there no loss during the process. For the mixing of the spices and the potato stew, we calculate the total will be about 200 kg per hour. And for the preparation of the protein dish, mixing of chicken with the curry gravy, the total will be about 700 kg per hour. For the packaging of the product, the cooked rice and the chicken curry will be packaged into 2 compartments. Then the loss is assumed to be 2 kg per hour, and the total will be at the outlet will be 2,098 kg per hour. For the retort sterilization, the needed trays of ready to eat meals, about 5 5,245 days per hour. And for the secondary packaging, since they are lost about 2 kilogram there, we are calculated the K needed will be 5,240 days. For the energy balance, preparation of the butter rice, doing the washing of the rice and the mixing of the butter rice, we are assume the system is closed and elevated we now work done, and they in steady state. Therefore, then the kinetic and potential energy are assumed to be negligible. Therefore, no energy are released and absorbed during the process. For the cooking of the butter basmati rice, we are calculated the Q will be about 1010 kilowatt per hour, and since our plant are working for 8 hours per day, the total energy required about 3 million kilojoule per day needed. Okay, for the preparation of the protein starch, the washing of the deboned chicken, dicing of the deboned chicken, dicing of the red onion, and the mixing of the spices and red onion, no energy are released and absorbed in this process. For the washing and the peeling, there are same assumption as before. There are no energy released and absorbed in this process. For the curry gravy production, also there are no energy released and absorbed. And for the mixing of the chicken with the curry gravy, the Q value will be 66 kilowatt per hour, and for per day about 2 million kilojoule. And for the packaging of the production, the primary packaging, there are also no energy released and absorbed in this process. For the retort sterilization, the Q value will be about 3 million kilojoule per hour, and the heat released to the surrounding about 4 million kilojoule per day. And the secondary packaging, it will require about 600 million kilojoule per day for this process.
So I will explain about the project location, criteria and plan layout. There are several considerations to make before build a plant. First, the land must be flat, and our raw material must be near to our plant location, and the transportation must be fast. Yes, and the utilities, the basic utility for our plant location must be power, water and water disposal. And as the every processing in the plant location must be have power, and the local supply, and the plant location must be near to the targeted market, and these are 3-4 law must be followed to prevent our plant organization from being fined or forced to move out. And the plant location decided, we decided to buy our plant location, which is a semi-factory with a 1.3 story, include the office and warehouse, which are located at Bandar Teknologi Kerajaan Semenyih. The price is estimated about the 4 million, and the place also near to our chicken supply, which is ayam ismi. And the impact of such selection, there are several impacts for society. Of course, the noise pollution, as the machine cause the noise, and the health for the emission of the gas and wastewater from the plant. And the safety, we must consider the safety, as our factory use steam that may expose to our workers. And we are following the guideline for the city and zoning for the industry, and the Environmental Quality Act to prevention and control of pollution and enhancement of the environment. Our plan layout are straight as flow, which to optimize the occupied area within the plant, and the work center are organized in the sequence period, and the first one is the raw material, and followed by the equipment according to the process. And also there are a fire extinguisher and a fire alarm for the workers to alert during emergency. And for the site layout, the dimension of our length and width of this land is 340 × 115 feet, and they are also the one direction. The one direction at the side layout. There are three main entrances at the side layout. First one is the administration. At the back one is the for rubbish and the receiving and raw material, and it's for distribution. And we also have a laboratory for analysis our product, and have a water tank, disposal sewage, and rubbish yard to disposal our product. And the production plant are placed according to our process in place at different compartment room to prevent the contamination.
So I will explain about economic feasibility study. So for the capital cost, there is a land purchasing cost, which is 4 million for our land cost. Then we also calculate the inside battery limited investment, which is using this formula, and then we get around 1 million. And then this is the equipment cost that we use, which is we use rice washing machine, rice cooking, potato washer, potato peeler, potato and analyzer, chicken meat washer, chicken meat cutting machine, chicken curry cooking, and packaging machine, and steam heating with cost 371,000. And then we also calculate the OSBL investment, which is used for utilities, common facilities, and other equipment. And then we also calculate the host of fee cost, contingent cost, and working capital. This is our total of capital cost, which is around 7,546,997. And then this is the operating manufacturing cost, which is expense that related to the operation of a business and operation of device and component. So we have also fixed operating cost. This is cost under the fixed operating cost, which is the total cost is around 1 million. And then we also have variable operating cost, which is include raw material cost, packaging cost, and utility cost. After that, we have overhead cost, and then this is the table that shows total operating cost, which is the total is around 31 million. And then we have income and expenditure, which is our annual revenue is around 88 million per year. Our gross margin is around 57 million, and then our cash cost of production is around 31 million. And then we have also net annual profit, which is 36 million, and we have also gross profit is around 48 million. And then is a financial analysis, which is have a depreciation charge and project cash flow. This is our depreciation charge for 50-year recovery, which is our depreciation is only 2.95%. And then this is our cash flow diagram. Our cash flow is increased, and our PV cash flow is in medium. And then we have return on investment, simple payback time, and internal rate of return. RRI is a discounted cash flow rate of return, which is interest when NPV is equal to 0. So this is a summary of financial analysis, which is show that our net profit is around 36 million, and then our NPV is 200 million, and then our internal rate of return is only 87%, and our simple payback time is 1.07 per year, which is quite good for our plan. And then our return of this investment is only 93%. So this is some recommendation for our plan design.